Hey everyone, in this lesson we are going to get started with generics. We're done talking about classes. We are going to jump into the topic that is, in my opinion, the most important topic in TypeScript. If you want to really get to understand the core of TypeScript, how actually TypeScript works. The main pillar, in my opinion, of TypeScript is TypeScript generics. They're really powerful. They're really confusing. Their syntax is really weird, but with right guidance, you are gonna feel right at home. Trust me. Now, before moving forward with this lesson, I have to tell you that I have covered generics in a lot of depth in my TypeScript course, which is on Udemy. The link is in every video of this tutorial series is description. So if you jump into description, that would be like amazing. And if you want to know more about them, you can just go ahead and watch my Udemy course. So I don't mumble there a lot. And that was when I was a little bit more fluent in English rather than now. Anyway, generics, we are not gonna dive really deep into this topic in this tutorial series because they get confusing way too quickly. And I have made sure that the way that we are going to talk about generics in the context of this tutorial series is to keep it lighthearted and simple and really approachable. All right, so let's get started. First off, what is a generic? A generic is a component or a piece of code that can be used over and over. Now, generic, if you know what it means in English, it's basically the same idea, the same principle in TypeScript. We want something general. We don't want something specific. So generic is the antonym of specific. So specific is something like you know exactly what that is. You can really pinpoint it. But generic is something that you can't pinpoint it. It could be anything. So that's what TypeScript says generic is. Now, but we're talking about TypeScript here. So what TypeScript has done is it has grabbed generics and it has made sure that it is generic in nature, but we still know about it. We can still pinpoint it. What I mean by that is, let's just take a look at some code examples. So let's say we have this function. All right, we're going to start with functions. The name of this function is game loop. Now, this function has a parameter. It has a type of number, and this function returns a number. Now, I'm going to say return param. All right. Now, the function accepts a number and it returns a number. Everything is cool. Now, what if I want to create one function to be able to accept a number and a string and a Boolean, any kind of data? Now, this function does not allow that. To be able to accept a string, we need to create a function, a separate function. Now, that's not what I want to do. I want one function to be able to do all of that. Now, you might be thinking that we could just go ahead and use the any type. So this function's parameter is going to have the type of any. This function returns the any type. Now, the issue with this implementation is that as soon as we specify the any type, we lose all the information about what goes inside the function and what comes out of the function. We don't know what that is. So we want one thing to get inside the function, and we want the same thing to be returned by the function. All right. So with the any type, I could provide an argument with the type of number to the function, and I could expect anything else from the function. In our current implementation, we would expect the same thing from the function, but we have no idea of how to type check this function. And using any, we lose all type safety that TypeScript provides us. Now, instead of using type any, we're going to talk about another concept. And that concept is called a type variable. Now I'm going to explain to you why it's called a type variable. The reason that it is called a type variable is that it can accept any kind of value. Now, think of JavaScript. When you declare a variable, you say number, 10, like age is 10, number, the numeric value. And then later on, you can change age to a string. You can change the variable to a Boolean. So it's like a variable, right? Now, in TypeScript, we talk about a type variable, not a variable that is variable. We talk about a type that is variable. So we talk about a type that could accept at the same time. It could accept number, or it could accept a string, or it could accept a Boolean. So in that sense, it acts the same way as our variable from JavaScript. It acts exactly like that. But when we use that, we will not lose type safety. So we will use a type variable, but we still have type checking. We still have all the great features of TypeScript. All right? If you're not sure, you can just rewind the video. I'm going to move on. Cool. You're going to see through the implementation what I mean. Now, for starters, what we are going to do is we're going to use the actual type keyword itself. Now, in front of this function name, let's zoom in a little bit. So this is the function name. I'm going to create these two angle brackets here. And within this angle brackets, it may look like an HTML element, but it is not. Within here, I'm going to write something in like the first letter is capital in Pascal case. Type. So this is going to be our type variable. Now, keep in mind, this is generic. We don't want it to be a number within the function declaration. We don't want it to be a string within the function declaration or a Boolean. That would take away from the flexibility of the function. So we want one function to work with any kind of data type, but at the same time, we have to be able to know what goes inside the function and what comes out of the function. And we still have our type safety and type features. So this is the type that is going to determine how the function is going to behave. Now, we want the same type to be the type of our parameter, and we want the same type to be returned from the function. All right. Now, okay, so I hope everything is okay so far, because I'm going to move forward. Now, we're going to dive into how we can execute this function. Don't worry about that. So let's say I have a result1 underscore 1 to make it a little bit more prominent. And in here, I'm going to write the name of the function, game loop. Now, there are two ways of going about this. The first way is we can use the type argument inference, or we can like specifically write the type that is going to enter the function and that is going to exit the function as well. So the same syntax. So we have the function name, and then we have, now this syntax, this is not something that I created. This is the syntax of generics. That's what I meant by weird. This is like unconventional. I shouldn't say weird. It's a little bit unfamiliar. Like you haven't seen, if you haven't worked with TypeScript, this is really weird to you. It's unfamiliar. It's like new territory, uncomfortable. And you see, okay, what is this? Now there is something else in the function declaration that I have to pay attention to. And it's really critical that you pay attention to this. Now, it's going to get really easily get used to if you just like follow along with this video. So I can use the same syntax. I can get the name of the function. In fact, I'm going to copy it and I'm going to put it right here. Now, instead of writing the type, now keep in mind, the function itself is flexible. It could be number, string, Boolean. But where do we want to be pinpoint? Keep in mind, in the beginning of this lesson, I talked about how TypeScript's generics are generic in the sense that the function accepts any value. But TypeScript also wants to make sure that it is pinpoint what type of value is accepted. But where do we apply that or implement that? That's where we want to use the function, like that's when we want to execute the function. So in the function definition, we keep everything generic, but in the function execution, we keep everything not generic, very specific, right? So in here, what do I want this type to be? I want it to be of type number. See, it's very simple. Now I open the function execution block, this parentheses, this executes the function. The first part, before writing the parentheses, you can see this is passing a reference to our function. I've talked about this. You have to really understand this. So game loop passes a reference to our function. And then since the function has a generic type, we need to specify what that type is. Even though that's generic, that's the idea behind the generic, to be generic and not specific. But I mean, this is TypeScript we are talking about. Let's be honest. We need to specify what type that is. Okay, then we need to provide the parentheses that actually execute the function. So in here, it requires an argument with a type of number. Now, this is really cool. Since I said that the type that the function accepts is going to be the same type, you can see the way that you know it's the same type is because it's the same word. If the casing of the word is different or the word itself is different, then you are dealing with two different types. We're going to talk about them in our upcoming lessons, but this is what you need to pay attention to. So this type is the same as the one that we have written in the parameter, and it's the same as the function return. So it indicates that this is the same thing. And the function, when we write it within the function like this, TypeScript says that, okay, so since all three of them are the same, and when you specify the first one as number, what I'm going to do is I'm going to go ahead and I'm going to say the other two are also numbers. And that's correct. So parameter has to be a number. It can't be like S, a string of S. It doesn't work like that. It has to be a number. So I could say like 100, and that is okay. And let's log this result 1, and there we go, 100. It's blue, it's a number. Now this is a generic function. Now this function not only works with a number, but it also works with any other type that you want. So result 2, but you need to specify the type. I mean, you don't have to, but it is a good idea to specify. Now in this function execution, I don't want the function to receive a number. I want it to receive a string. Now as soon as I open parentheses, since the type is the same thing in all three places in our function declaration, TypeScript knows, okay, the game loop function receives a string. The parameter has to be a string, and a string is returned from the function. So in here, I'm going to say like 100, the string of that. And if we come here, let's, come on, buddy. Let's save that, jump here. There we go. So the first one is a number, second one is a string. Cool. This is function declaration is generic, but function execution is specific. This is TypeScript's idea of a generic. It's not generic, it's generic specific. I'm doing air quotes in case you're not seeing me. All right, so far everything is all right. But there is one more thing that I want to talk about, which I briefly hinted at, and that is a type argument inference. Now, if you find this a little bit uneasy and you think, okay, this is, do I have to write this? I mean, if you ask me, this is actually good practice, because if you write this code, as soon as I take a look at the function execution, I know what this function is, and what it is going to expect that I enter in the function. I know exactly. But if you don't write it, TypeScript is going to be pretty awesome in figuring that out. So let's actually practice that as well. Game loop. Now, I'm not going to specify what the type is. I'm going to let TypeScript type argument inference it for us. And in here, I'm going to say true. And log. And if I hover on the variable, we didn't hover on the actual variable names. So if I hover on result 1, we can see it returns a number, since this is a number. If I hover on result 2, it returns a string. Since we passed in a string, we specified in here that we want a string. And in here, this is Boolean. There we go. Let's result 3 it. And let's come here. It's true. The type of it is Boolean. So that's it for this lesson. Let's jump into the next one and let's keep talking about generics.